Okay, guys, so as you might have heard, teacher's going to be out again for another week, so we're going to start a new topic, and the topic is called measures of central tendency. Okay, so we've got measures of central tendency. Now, a central tendency is actually what is the overall pool or the measure of center. Okay, often you guys might have heard this as an average. Okay, now an average is just what is the norm. Okay, an average is also a norm, and it is also often referred to as this symbol or that symbol. Now, this symbol is the Greek letter mu, and this is often referred to as x bar. Okay, now another word for average, okay, average is also the same thing as the mean. Now, whenever we're looking at data, okay, for instance, we've got a bunch of discrete data plots, right? So we've got a bunch of discrete elements that measure up to form data, and let's just say this is the overall time, and let's say time taken on exams, and let's say this is percent passing. Okay, so when we use data, we actually want to measure the central tendency, and normally statistics is used for relationships. Oops. Okay, so normally when we're talking about relationships, we're talking about data that involves some form of causality, a how and a why, a when and a where. Now, relationships are what we call discrete functions. And discrete functions are not always continuous. Discrete functions can be made up of central data elements, where we know that the central element or the central pole would be like that. It would be right there, it'd be that center element. Now, normally we would know that the data would measure this. Okay, and that would be an example of a regression line. Okay, and we use that in statistics to talk about many different things. Basically, it's like a prediction of the norm. Okay, now a norm can be also like a behavior. A norm is also expected value or expectation. Now, an expectation is basically the prediction that something will most likely happen in the near future. Okay, so you can talk about behavioral sciences, you can talk about many different things. But basically, the three common most measures used for central tendency, okay, are basically mean, median, and mode. Okay, so we've got the mean, median, and the mode. Okay, the mean is often referred to as x bar, and it is literally the set of all elements added up together. Okay, set of all elements added up together divided by the number of elements you have. Okay, now the median is the middle number in the data set. And when you're trying to find the median, always order your data set from least to greatest. Okay, the mode is the number that repeats the most often. Sorry about that. So the mode is the number that's repeated most often. Okay, so let's just create a bunch of stuff here. So on example 1, you have a bunch of salary data. Okay, so we've got salary data. Now, on salary data, we know that Alan makes $40,000. We know Baker makes $42,000. And we know Chase makes $59,000. And we know Dietz makes $60,000. And we know Eckert makes $62,000. Francis makes $65,000. Now, the mean, or the average, is literally equal to 40,000 plus 42,000 plus 59,000 plus 60,000 plus 62,000 plus 65,000. And once you have that all added up, we're going to divide by the number of elements in the data set. Well, we know that we have 1 element, 2 elements, 3 elements, 4 elements, 5 elements, and 6 elements. So I'm going to divide by 6 people. Now, what you'll get if you find the average is that the average is equal to $54,667. Now, the median is the middle number. Now, since we have an even amount of elements, we have to add the two numbers, the two values of the elements that occur in the middle, and divide by 2. So the median is equal to these two numbers added together and divided by 2. So the median is equal to 59,000 plus 60,000 divided by 2, which is equal to 59,500. That's the median salary. The mode, there is none. Now, the reason why there is no mode is because none of the salaries repeat. So there is no mode. Okay? Each element, each term, the Allen term, the Baker term, the Chase term, the Dietz term, the Eckert term, and the Francis term are distinct values. So, with that being said, there is no actual mode of this data set. Okay, let's look at a section where we actually have different types of things. Let's look at backpack weights. Okay, let's say we've got a data set of 3, 4, 4, 4, 6, 7, 7, 7, 7, 7, 8, 8, 9, 9, 9, 9, 9, 10, 10, 10, 10, 10, 10, 13, 15 pounds, 15 pounds, again, 16, 17, 20, and 33. Okay, these are all backpack weights. This is example number 2 in your packet. Owen is a member of the student council and wants to present data about backpack safety to the school board. He collects data on the weights of backpacks of 30 randomly chosen students. How much does the typical backpack weigh at Owen's school? Well, we know that the mean is all of the elements added together. So the mean is equal to X bar, which is equal to the sum of all the elements combined divided by the number of elements I have. So basically what this becomes is I've got 3 plus 4 plus 4 plus 4, and I'm not going to do it all by hand. So I'm just going to say plus dot 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 plus the last term, which is 33. And we're going to divide by the number of elements we have. In this case, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. So I'm going to divide by 30. And if you put it in your calculator right, you'll find that the x bar, or the mean, is equal to 10.2 pounds. Okay? Now the median, if you look at it, is the number that is in the middle of the data set. Now I've got 30 elements, so 30 is even, so I have to take the middle numbers. In this case, I've got, I would take where I have an even amount on each side. And I have to take two numbers, add them together, which the two numbers in the middle, and then divide by 2. In this case, it would be 2 9s, okay? So I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16, where I have 14 on each side. So I have 14 elements here, and then I have 14 elements on there. So basically, I'm going to take 9 plus 9 divided by 2, which is obviously 18 divided by 2, which is obviously 9 pounds. Okay? The mode is the number that repeats the most often. In this case, the mode is 10, because 10 repeats the most often. So I've got 10 pounds as the mode. Now, if we look at a box and whisker plots, okay, a box and whisker plot can actually be used to model the overall spread of this data. Okay, so in this instance, we've got a box and whisker plot. And a box and whisker plot is basically a box separated out into 5 distinct components. Okay, part of the components are given right here. This is Q2, this is Q1, and this is Q3, where this is the minimum of the data set and this is the max. Now, Q1 and Q2 and Q3 are called quartiles, okay? So this is a quartile, this is a quartile, and this is a quartile. Now, the cool thing about quartiles is quartiles are actually medians, okay? Now, the quartile 2 is equal to the median of your data set, the entire data set. Okay, so in this instance, we know that the median, we said, is 9 pounds. So this is 9 pounds. That is Q2. The max would be 33. Now, assuming there are no outliers, the max would be right here, 33 pounds. Okay, the minimum would be 3 pounds, so I know that's 3 pounds. Okay, now in order to find Q1 and Q3, I have to actually find the median of the data set where it got split up from the overall median of the data set. So now I have 2 components, okay? I have this part that I've separated after I took out the original median of the data set, right? And then I have a second part of the median, and I'll do this in purple. So now I have another component where I've separated off the median into 2 more components, okay? So I've got Q3, and then I've got Q. So, and then I've got Q1. Now, Q1, I have to find the median of Q1. Now, the median of Q1 is equal to, I look at how many I've got. I know I have 14, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I'm going to take the 6th and the 7th one, where I've got the same amount of elements on each side. Okay, so I know I've got 1, 2, 3, 4, 5, 6, 7. Okay, so now I've got 5 on this side. Do I have 5 on this side? The answer is no, so I have to leave 7 over here. So I'm going to take this 7. So now I'm going to have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I'm going to add 7 and 7 together. So 7 plus 7 equals, divide that by 2, equals 14 divided by 2, because it's even. And you find that the median of Q1 is 7 pounds. Okay? To find Q3, I'm going to have to find the median of Q3. So the median of Q3 is actually equal to another even data set. So I have to go 6 out. So 1, 2, 3, 4, 5, 6. Add that one and this one. So 10 plus 13 divided by 2. So 10 plus 13, divide that by 2. Okay, we'll scoot that up. And that's equal to 23 divided by 2. Or as in this case, if you take 23, divide that by 2, you're going to get a decimal, which will be 11.5. Okay? So right here, I've got 11.5 pounds. Okay? Now, each one of these marks the overall spread of the data. Okay? Now, this is the median of the upper quartile range. This is the median of the lower quartile range. This would be the median of the entire set, where these would be the minimum and maximum values that occur within your data. So this should get you guys started, and I hope this helps.